All right, all right. Dobro utro, guten morgen, good morning, and a very warm welcome to day 2 of DevReach 2018. Hopefully all of you enjoyed day 1. We have had a full night's rest, and we are back at it with all our energy this morning. So welcome again to DevReach. We are so delighted to have you here. Now, we talked about a few things yesterday. We are trying to make this anniversary edition an event that you all can remember. We are trying to do a lot. There were we have three wonderful keynotes lined up. We have 46 plus sessions by some of the most amazing speakers from around the world. Behind the scenes, we are trying to juggle a lot of logistics, and sometimes things are not going exactly as per plan. So I do owe you all a sincere apology for a couple of things yesterday. A few sessions were very full. We kind of knew that going in there's a risk, and we wanted to have this big keynote theater all day, but it just wasn't available. So bear with us. And then for the schedule, we had a couple of schedule changes yesterday, and we tried to communicate. We'll try to do a better job today if there are any. The latest schedule is on the website, so that's the one you should check. As is the norm with any conference, the moment we print a schedule, things start going out of sync. So that's the schedule. I don't foresee any schedule changes today. We, in fact, added a new session this afternoon, so please come for that. And if you're a fan of Richard Campbell and .NET Rocks, we are doing 2 live panel discussions this afternoon, so come and join us for that. Should be fun. All right, so it's going to be a busy day again today. 1 opening keynote, 1 closing keynote, and again, lots of sessions in between. Enjoy your coffee breaks. They are by Uva Group, and they were serving ice cream yesterday afternoon. So thanks for all of that. Lunch, again, will be a little quick, because again, we're trying to jam in a lot of content in a single day. We have a history, again, of supporting a social cause, and the Because Foundation is here. If you have not, please go see them at the booth. Take a picture, put yourself on as a magnet. You can get some handcrafted things that you can buy for them. So please support a good cause. Like we said yesterday, we are very fortunate to have some wonderful folks who support us as sponsors. Today, more than yesterday, you really should go visit all of their booths, because it gets you in to win some wonderful raffle prizes. We have some really cool tech gadgets to give away, so please visit all of our sponsors. That's what gets you in to win these prizes. So thank you again to all of our sponsors. Now, let's get some things clear about the closing and the prizes today. We will come back here at 4:30, and we're going to have a closing keynote, which should be inspirational. So please come back here. Again, we may not fit everybody here, so we will live stream that to 2 other theaters if you want to go there. But at the end of it, when we do the raffle prizes, the streaming is one way, so we cannot have it everybody in other theaters, and you need to be present to win. So please come back here for the raffle prizes, and it should be a quick 15-minute thing, and hopefully you can walk out with some really cool tech prizes. Okay, again, we have seen this yesterday. We are live streaming this to YouTube, so you can watch this later on. In between sessions, I know it's busy, but take a minute to give us some feedback on the sessions. We have some amazing speakers, but we could all use some feedback. So take a minute, give us a little feedback on how you feel about the content that you see this year at DevReach. And then, when everything is said and done, we can all stretch our legs and relax today. We can eat, drink, and be merry. It's our 10-year anniversary, so obviously we're going to celebrate. We're going to have a nice kick-ass party. Stefan's going to be there with the band. It should be a good time. It is 10 minutes away in Hotel Grammy, so please come and join us for that Andy party at 7. And like I said, we won't go home until you are tired and you want to go home. Okay, so it's going to be a good, fun night. Let's start this morning. It's a good face. With our good friend, Burke Holland. You kind of see the trends with AI and machine learning. It's all over. Are we doing the right things? Are we doing the ethical things? We are delighted to have Burke back with us this morning, and he's going to show you more real-world applications of machine learning. What can we do with it? Now, those of you who are veterans of DevReach will remember that Burke used to work with us at Telerik. He may be with Azure now, and he's changing the world, and he's bringing software to the cloud 1 app at a time, but I'm pretty sure a big part of his heart is still with Telerik. So we are delighted to have Burke Holland on as a keynote speaker today. Burke, welcome on board.
Thank you, Sam. Geez, that was a giant picture of my face and quite the intro. All right. Oh, perfect. Good morning. Jeez. Tough crowd. All right. I understand it's early. How's everybody feeling? All right? Yeah, oh, geez, one person is really excited to be here. The rest of us are kind of like, I don't know. I could take it or leave it, buddy. Move on. This is Janelle Shane. Janelle is a research scientist, and she works in optics. She also does some very interesting things with artificial intelligence and machine learning and neural networks and AI. And she runs a site called AIweirdness.com. And you can probably tell from the name of this site that she's not doing the typical things with AI. She's doing some very interesting things. And Janelle's very interesting because she's asking if AI and neural networks and machine learning can do unconventional things. So not like picking out a face from a picture or understanding speech, but very interesting things. Things like, can you teach a computer to tell jokes? Humor is very complex. Is it possible to generate an algorithm that can then generate humor and jokes? There's a gentleman that works as a data scientist at Netflix. His name is Vineeth Masra. And he has a TED Talk where he talks about how difficult it is to put humor into an AI, but how essential it is because humor defines the way that we interact with each other. Humor helps us to navigate uncomfortable situations, and it helps us when we're stressed out and we're not exactly sure how to cope, like standing in front of several hundred people, giving a keynote. Jokes can help diffuse the situation. Yeah, thank you. Jokes like, what do you call a pile of cats? Anybody? A meowtown. Or how do you get a sheep into a box? You just ram it in there. Easy. Lastly, my favorite one, how do you know if someone uses Vim? Don't worry, they'll tell you. So what Janelle did is she took a bunch of these jokes. If you notice, these jokes have a very similar format. What do you call A? What do you get if you cross A? How do you know if? And she ran 43,000 of these jokes into a neural network. But it turns out that humor is extremely difficult, and computers have a very difficult time with it. They specifically have a hard time with puns, which are a play on language. The good news is the results that came out of this thing are so bad that they're actually pretty funny. Do you want to see some of them? Yeah. All right. What's black and white and red all over? A confuse on the bull. Or this one, how many engineers does it take to change a light bulb? A star, an alligator, and because they are bees. Now, what you'll notice here is that the computer is actually starting to sound like a child. If you've ever had a child before, children go through this phase where they try to learn to tell jokes. Anybody in here a parent that's had a child that does this? Mine did this too, and this is exactly what they do because they don't understand language and puns, sarcasm, and irony. These are very complex things, so it's hard to do. Last one, my favorite. Why did the neural network crash? A Jax when he was the stop get a cheese problems? Because they have to kill? Because they are dogs. So it turns out humor is very difficult to do and not something that we can teach computers to do very easily just yet. My name is Burke Holland, and I work at Microsoft. This other person here is Jasmine. She's not with us this morning. She's back in New York, but she worked on this project with me, so much of the work that you'll see here today was done by Jasmine. And just like Janelle, Jasmine and I were very interested in machine learning, and specifically, what can we do with machine learning that we're not already doing? Can we solve very, very difficult problems? Can machines do the things that we can't easily do as human beings and do them quickly? About a year ago, this time, she and I were in an internal training together in Redmond at Microsoft. And Microsoft had everybody come in so that we could get training on how to do machine learning, how to build machine learning models, and how to use Azure Cognitive Services. And just like your company, Microsoft's internal training is just brutally boring. There's just no way around it. It's days long, everyone's exhausted. And so we were sitting in the back of the room, and it was about 4 in the afternoon on day 2, and we had stopped paying attention hours ago. But we couldn't really leave, so we're there, and we begin to talk, and in the back, we begin to talk about machine learning and AI, because in the boot camp, what we're doing is we're building models to do things that are kind of mundane. So we were building a predictive analytics model to determine what the price of a car would be based on historical statistical data for cars. Not super exciting. And so we begin to talk about what are things that AI could do that would be really, really cool. What problems could it solve that are super complex? And then we begin to talk about a different subject. How many people in here follow a Twitter parody account of some sort? Anybody? Couple of folks. Does anybody follow the Common Squirrel Twitter parody account? Rob does, okay. A couple of folks. Yeah, so the Common Squirrel account is a Twitter account for a squirrel in Boston, Massachusetts. And all it does is chronicle the life of a squirrel in Boston. What squirrels do. They blink, run, stare. So this is what this Twitter account does. The whole feed for Common Squirrel is just this squirrel. And the Common Squirrel has way more followers than I do. And most of these tweets get way more engagement than mine, so obviously I'm doing something that's way wrong. But people love this stuff. We love Twitter parody accounts. They become a very important part of our social fabric. Another great one. Who knows this one? This is probably, several hands for this one. This is probably the most famous Twitter parody account, I think, right now. This is a parody account of Elon Musk and what he might say or what he might tweet when he's bored, sitting around with nothing to do. Because, as you may know, Elon Musk tends to do very crazy things when he has free time on his hands, like dig giant holes and fly rockets to the moon. And that's why we love him, but it's, kind of crazy. What's he going to do next? So here's some examples. This is a good one. I like this one. Another one, which, not a terrible idea, just sort of a inverse on the current situation, which is just the opposite. And then every now and again, they tweet something that's actually pretty wise. This is an old maxim, but still a good one. So Jasmine and I had begun talking about Twitter parody accounts. And we, in particular, were interested in the parody account called Horse.js. How many people in here know who Horse.js is, the parody account? By a show of hands, how many people have heard of this account? A couple of folks. So Horse.js is an account that came online back in about 2011, about 7 years ago. And the Horse.js account was never meant to be a long-running parody account. Someone in the JavaScript community, who's fairly well-known, created the account and then began to tweet from this account. And since 2011, they have tweeted around 7,000 times. So what does Horse.js do? Horse.js tweets what you tweet out of context. So let me show you what I mean. Here's a good example. So in this one, right, this is somebody asking a legitimate question. But when Horse.js tweets it, it's completely without context, and it's hilarious. So if you don't follow Horse.js, this is a great account to follow. You'll see all sorts of tweets that are just like this, out-of-context tweets. Now, Horse.js is not the first account to do this. This is actually a copy of a parody account called Horse eBooks. And Horse eBooks did the same thing. It was a guy sitting around just out-of-context tweeting ebooks. That account became so popular that he eventually sold it, I don't know to who, for $250,000. Yeah. So Horse.js is sort of the JavaScript equivalent of that. And as we sat around, bored in the back of the room, we begin to ask ourselves, what if we could take all of the data from Twitter, throw it up into Azure, push a button somewhere, and have Azure tell us, using AI or machine learning, who Horse.js is? Is that possible to do? Now, keep in mind, at this point, we know nothing about machine learning or AI. We have virtually no experience nor any real knowledge about the things that you would do with AI besides the conventional things. So what we did was we created an abstract for a conference called JSConf in the US. It's a very, very popular JavaScript conference. And we submitted the abstract with this idea that we would do a talk about how we used machine learning to discover the true identity of Horse.js. And about a month after I submitted the abstract, I got an email back, and I thought, oh no. And I called up Jasmine. I said, Jasmine, we have some bad news. They've accepted our talk, and now we actually have to do this. This is a real problem. So that's how we started with Project Horse, and that's what we're going to walk through this morning. I'm going to show you exactly what we did and what we learned along the way. The conclusions that we'll get from this are probably not what you're expecting, but that's typically the way that things go. So the first thing that we did was we started with some initial questions that I'm going to go over with you. We had to have a starting point because it's really hard to know exactly where to start. As it turns out, you can't just upload data into Azure and push a button and have it magically tell you answers. That feature does not yet exist. Someone should build it. It's not quite there yet. So you have to know where you want to start from. We're going to look at some of the assumptions that we made. The assumptions drive the conclusions. Again, you have to start from somewhere. And in order to do that, you have to make some assumptions about the current situation. What we do here today is going to be more similar to forensic science than it is going to be to machine learning. We spent a lot of time just dealing with the planning. We interviewed several people, talked to some experts just to figure out what to do, because just like you, we're front-end developers. I'm a JavaScript developer, Jasmine's a .NET developer, and we just didn't know how to start. And then we're going to go over how we built it. I'm going to show you actually the technology that we used to build this, the way that we went about doing this. And then finally, we'll look at the results. And I'll show you what we found. We'll look at the data together. All right, so let's start with some of the questions that we asked here. What tweets does Horse.js react to? There are obviously certain tweets that Horse.js thinks are funny enough to tweet out of context, and others that it doesn't. Are there certain tweets that cause Horse.js to react? Does it have a trigger? When is Horse.js active? Is it consistent? Does it occur only in specific times? Is it sporadic? Are there certain accounts that Horse.js reacts to? In other words, are there certain people that we could identify as being in Horse.js's sort of small group of friends? In any given crime, if you talk to a crime expert, a detective, police officer, they'll tell you that for any given crime, you will make 20 mistakes that point directly to you, which is why it's very difficult to commit the perfect crime. And when you're committing a crime, anonymity is paramount. So we wonder, does the same thing apply to Horse.js? Have they made critical mistakes and slipped up in revealing their anonymity? And then lastly, is it one person or is it multiple people? In other words, if multiple people have access to this account, it's going to be very difficult to figure out one of them, let alone all of them. And actually, it would be impossible. So based on those questions, we made some assumptions right out of the gate. Since we had to have a place to start, we just decided we were going to make some assumptions and then go and see if those assumptions were true or false. Now, what we're doing here is very close to the scientific method. It's not exactly the scientific method, but it's close. We're starting with a hypothesis, asking a question. We're going to go through, run an experiment, and see what our conclusions are. So the assumptions that we made is that Horse.js is a Twitter user, obviously. But what we mean by that is that it's not a bot. It is a real live person sitting behind a keyboard or a smartphone tweeting. Horse.js is a web developer. This one's important because if they're not in the industry, it's also going to be hard to find them. So in other words, if they're a real estate agent and then in their free time they quote tweet JavaScript, it's going to be really hard to figure out who that person is. So what we're assuming here is that it's somebody in the tech community on the JavaScript side that we could identify. We also thought that the person who's behind the account probably follows the account. That just makes sense. I mean, think about it. If you were running a parody account, would you not also follow that account so that you could see what the replies were and what the reactions were? Don't people usually return to the scene of the crime? They do. It makes sense. We also assume that Horse.js is a single person. I don't mean like Horse.js doesn't date. I mean like Horse.js is only one person. It's not multiple people because, again, that would have added an exponent to the problem and made this very, very difficult to determine. And this one's important. Jasmine brought this one up, and it kind of threw us for a loop for a while, but it is possible in Twitter to have a private list of followers that nobody else can see. So if you look at the Horse.js account on Twitter, they're not following anybody. I think they follow one account, and it's another parody account. So if you don't follow anyone in a social graph, it's very difficult for me to draw connections between you and anyone else because you're not a part of the graph. However, I can draw roundabout conclusions by looking at the people who follow you and then looking at their followers. But if you're looking at a private list of people, it becomes much more difficult to do that on Twitter. It's just another way to maintain anonymity. And then lastly, we assumed that machine learning is the answer to everything, right? This is a hard question. Machine learning is supposed to be the future. Surely it can solve this problem. So with that in place, we then looked at each other and said, how in the world are we going to do this? We just had no clue where to start. And so we spent about 3 weeks on the phone with each other. And each time we would spend about 30 to 45 minutes in a meeting, and we'd be like, all right, we're going to get together. We're going to start this thing. So we'd get together. We'd be like, what are we going to do? I don't know. How do you think we should start? I don't really know. I'm going to Google this thing. You check out that thing. So for 3 weeks, we got no progress at all. And then finally I said, we need some help. We're not going to be able to get this done on our own. And so we got some help. This is Dr. Vadim Karpasenko. He has a PhD in computational biophysics. I don't know what that is, but it sounds very smart. Vadim works with us at Microsoft, and he works specifically on the AI and ML team. And Vadim knows a whole lot more about this stuff than we do. So we got Vadim on a Skype call, and I explained what we were trying to do. I said, Vadim, we're trying to figure out if we can take all of this data from Twitter, run it into some sort of a model in Azure, and have it tell us, looking at the social graph, who statistically is most likely the person that is running this account. And he said, can you repeat that? Skype cut out there for a second. Because that's how Skype calls go these days. So I repeated the whole thing. And he said something very interesting, something that I was not expecting him to say. And he said to me, you don't have a machine learning problem. What you have is a statistics problem. So what Vadim is pointing out here is that the problem that we really have is that what we really need to do here is some statistical analysis. And machine learning can help by running statistical models, but the analysis really has to be done by us. This is something that we refer to today as data science. Who in here wants to be a data scientist when they grow up? All of us, right? Such a cool job title. Don't you want to tell people, like, what do you do? Oh, I'm a data scientist. It's not that big of a deal, right? Of course it is. You're amazing if you're a data scientist. So this is one of the first hard lessons that we learned in this project. And I think that Matt Veloso said it best. Machine learning is not the answer to everything. It's not SharePoint, all right? It's for all my SharePoint people out there. We love you. This is one of the problems that we currently have with AI is that we love it. It's so cool, but we're not exactly quite sure where to plug it in. Now here's the good news. This project does contain some machine learning, and we'll look at that here in a second, but by and large, this is sort of where you will find yourself with machine learning, which is to say that you might not need it. You might not need to plug it in. I know that you want to, but a select statement might actually be what you're after. All right, so let's look at how we went through this project. The first thing that we did was we had to go back and get all of the tweets that we could from Horse.js. All right, Horse.js has been online since 2011. It's tweeted over 7,000 times. We decided that 2 years or 24 months was enough data for us to figure out who Horse.js was. That seemed like a sufficient amount of time. So we pulled 2 years of data out of Twitter, and we immediately discovered something very interesting. And that is this account right here. This account is called Horseplain.js. And Horseplain.js is essentially a witness to all of Horse.js's crimes. So what you'll see here is there's the Horse.js tweet, and then the Horseplain, all it does is it responds with the original tweet. Now, this was a huge break in the case for us because what this does is it stops us from having to go and do this research ourselves. We don't have to search Twitter to try to find the original tweet, so we now have an entire other data set to work with. It's not just the things that Horse.js tweets, it's also the original tweet that went out. So what we did was we built a system. This is Azure Functions up here on the top left. We built a set of serverless functions, and what they did was they just pulled data in from the Twitter API. And we pulled in 2 years of tweets, all of the Horse.js tweets, and all of the original tweets. And we took those and we stuffed them all into Cosmos DB, which is a NoSQL database. And then from that NoSQL database, we pulled out and did our analysis ourselves to figure out who Horse.js is. And then some of that data we ran into Azure Cognitive Services, which is the machine learning portion of this talk. And then we used the data out of that to help solidify or back up our case that we knew who it was. So our serverless functions kind of look like this. We have a project called Horse Hunt, and it's got two types of functions in it. We used a JavaScript to do this, so we wrote JavaScript serverless functions with Node. We have timer triggers, and we have HTTP triggers. Our timer triggers pull the data in from Twitter. Now, Twitter rate limits any requests. So you can get, say, 500 tweets at a time, and then you get a 404 error or a 401, and an error code, and you have to stop and wait for the amount of time designated by the API. It's actually in the error message, and then you can try again. But this presents a very specific problem, which is to say that new tweets are always coming out, and you have to backfill old tweets, so you have to understand the state that you're in at all times. So what we did was we stored the state of our calls in Azure Table Storage, which is part of Azure Functions, and then we'd have our functions wake up, process again. The HTTP triggers that we wrote simply grab the data out of Cosmos DB and expose it via a RESTful endpoint. That's all they do. Because we didn't want to spend a lot of time building up an API, Azure Functions worked great for that. This is what the database looks like. When we first got started with this, Vadim told me, he said, the biggest challenge you're going to have in this project is the sheer amount of data that you're working with. And I thought, how bad could it be? Right? It can't be that bad. I've worked with a lot of data before. It was horrible. So up here we have the Horse.js tweet. So the tweets have the same sort of, I don't know why I'm doing this. You can't see the laser pointer. So up top we have the Horse.js, and at the bottom we have the original tweet. Now, what I'm showing you here is a portion of the JSON response. But the responses that Twitter sends back are enormous. There are hundreds of fields and properties in these JSON documents. And the problem is you're not entirely sure which fields you need and which ones you don't, because you're at the beginning of the project and you're not entirely sure which of the data is relevant and which of it is not. And then we used Azure Cognitive Services Text Analytics. So this is something that you would expect machine learning to be able to do, and it can. So what we did was we ran all of these tweets through Cognitive Services, which would tell us a couple of very important things. It would tell us whether or not what the sentiment was, positive or negative, and it would tell us what language it was in. So does Horse.js tweet ever tweet in any other languages? The answer is no, it does not. And then, even more importantly, it pulled out key phrases. Now, this is actually going to be the thing that puts us over the top in the end, because it's just another data point that we can look at, because when we look at the key phrases, when we make a chart of those key phrases, there's going to be some that stick out like a giant sign pointing towards Horse.js. All right, so from all of that, are you ready to look at the results of the data that we had? All right, yes. Like, enough, dude. Move on. Show us, tell us something. Jeez. All right, so the first analysis we did is something called a time series analysis. And all this is it's looking at the data as it occurs over a period of time. So let's do that. Every dot that you see here is a Horse.js tweet from the last 2 years. Every dot represents one tweet. On the bottom, you have the day, okay? And on the y-axis, you have the time. It goes all the way up to 2500 because we're using Chart.js, and I don't know how to use Chart.js. I'm sorry, Chart.js, you deserve a better developer than me. But this is what we ended up with. Now, you should be able to look at this chart, and you should be able to tell me something just by looking at it. What is happening right here? They're asleep. They're sleeping. This chart tells us so much about Horse.js. Number one, it tells us that they are likely one person, because this is so consistent. Horse.js is getting a very healthy 7 to 8 hours of sleep every single night. They're taking very good care of themselves. Except for a couple of nights here, Valentine's Day and New Year's Day. We're doing all right. This also tells us what time zone Horse.js likely lives in. They go to bed at about midnight to 1 o'clock. It's about 12:30-ish. And they get up around 7 to 8. That being the case, we can narrow down their time zone to either Eastern time in the US or Central time. If they were in Pacific time or Mountain time, they would be going to bed at like 9 or 10, and that just does not seem like a developer to us at all, right? So the next thing we did was we took all of the original tweets, or the tweets that Horse.js has quoted, and we ran those in, and we plotted those. And you see something very similar, okay? It's a little less pronounced, but it's still here. And when we saw this, we had this idea, what happens if we look at these two things together? So this is all of Horse.js tweets overlaid on top of the original tweets. And what you'll see here is that there are some places where there are very bright pink dots. Here, here, here. What does that tell us? Does anybody know why those dots are bright pink? They're happening at the exact same time. So by accident, I made these circles like a little bit transparent, and when you put the red over the blue, you get a light pink. And so what's happening here is these two things are occurring almost simultaneously. In other words, someone tweets, and then Horse.js immediately tweets. And what can we learn from that? Possibly that Horse.js is directly following that person. So what we did was we pulled in all of those people and all of their followers, and then we just said, which followers do all of these people have in common? So if you take just the tweets that occur within 60 seconds of each other, in other words, someone tweets, Horse.js almost quotes it almost immediately. That is almost immediate. There's only, 6 of them? So we've drastically reduced the data set at this point. And now if we compare these two things, we look at all of the followers that they have in common, here's what we get. So this is another lesson that we learned, which is that a lot of times you don't know what the answer is, and you don't know that you're running into a road that goes nowhere until you spend weeks going down it. I feel like this is what law enforcement professionals feel like day in and day out. The next thing we did was what's called a frequency analysis. The frequency analysis just looks at how often Horse.js quotes certain people. So here's the graph here. I've blurred out the names at the bottom to sort of hide things here. But you can see there's a section of people that get tweeted a whole lot. And this person over here actually gets tweeted a whole lot more than others. Now, if we take this set of people here in this chart, all of them, and we pull out just the ones who live in the Central or Eastern time zone, it looks like this. Now, you can't see this, but this is one person in Austin and 5 people in New York. There are 6 people. We have drastically reduced our data set here. Then we ran a text analysis, and this is where we used machine learning. And we asked Azure to tell us, for all of these tweets, what does Horse.js like to talk about the most? What triggers Horse.js? It looks like this. This one right here is far and away Horse.js's trigger. And then finally we have the piece of evidence that Horse.js has forgotten, the slip up in anonymity. When you tweet, Twitter records the source of your tweet. Could be iOS, could be Android, could be the web, but it records the source. This is what Horse.js's source looks like. Twitter for web, and Twitter for Android. Of those 6 people that we had on our map, 1 uses Android. And in fact, of all of the people in the frequency analysis, 1 uses Android. So let's go over what we know about Horse.js. We know that they're located in the Eastern time zone, likely New York. We know that they tweet about certain subjects more than others. In this case, that's Ember. We know that they're likely one of our suspects, and we know that they use Android. So at this point, we have enough information to determine who Horse.js is with some margin of error, but we feel pretty confident about it. Are you ready to find out who it is? Nobody cares so much. All right, here we go. Can we just do a drum roll or something? Like for the great reveal? Yeah. Look, parody accounts wouldn't be that much fun if I just told you who was behind it. I can't just do that. That's going to take all the fun away. If you do want to know who Horse.js is, come and see me. I'll be glad to tell you in person. But I don't feel comfortable revealing this person's name, although I have verified with them that they are, in fact, Horse.js. So we did have success in the project. We were able to figure it out. But the one thing that I want you to take away from this presentation, let's go back to this tweet right here. Machine learning is not the answer to everything. It is one piece of a solution that you are already working on. Whatever solution you're currently building is going to be comprised mostly of conventional methods. Where does AI help us as developers? In the case of Azure Cognitive Services, which is just a set of APIs that you consume, you just plug them in a place where you can use them. Thank you so much for having me here this morning. Jasmine thanks you as well. And again, if you would like to know who Horse.js is, I'll be happy to tell you. Please come and see me after this talk. Thank you.
Thank you so much. All right, so that was super fun and enlightening. Thank you very much, Burke. That's it for the general sessions this morning. Enjoy the rest of the day. Come back here for the closing and prizes, and we'll have a lot of fun this evening. Thank you all so much.